We often look up at the night sky and see the moon. It feels familiar, a constant companion to our planet Earth. We call it the moon, as if it's the only one that truly matters. For centuries we have thought of it simply as our moon, a satellite orbiting our world. But what if this simple idea is wrong? What if the moon is not just a moon? This question might sound strange, but it is one that scientists have been asking. It challenges a fundamental idea we hold about our place in the cosmos. This is where a fascinating idea comes into play, the double planet theory. This theory suggests that the Earth and the moon are not a planet and its moon. Instead, they are a binary system, two planets orbiting a common point in space. Imagine two dancers holding hands and spinning together. Neither one is truly orbiting the other. They are both moving around a shared center. This is the vision the double planet theory presents for Earth and the moon. When we think of moons in our solar system, we often picture tiny objects orbiting giant planets. Look at Jupiter or Saturn. They have dozens of moons, but most are small, captured asteroids or icy bodies. The Earth-Moon system, however, breaks this mold. Our moon is unusually large compared to its planet. It is more than a quarter the diameter of Earth. This size difference has a profound effect on gravity. The moon's gravitational pull is strong enough to influence Earth in significant ways. We see it every day in the rising and falling of our ocean tides. The moon pulls on our oceans, creating a bulge of water that follows it as it orbits. But its influence goes deeper. The moon stabilizes Earth's wobble on its axis. This stability has given our planet a much more predictable climate over billions of years. The Earth-Moon system behaves less like a traditional planet and moon, and more like a binary pair. This uniqueness is what fuels the double planet theory. The idea of the Earth and Moon as a double planet is not a brand new concept dreamt up yesterday. It has roots that go back decades, proposed by scientists who looked at the data and saw something that didn't quite fit the standard picture. George Darwin, who was the son of the famous naturalist Charles Darwin, was an astronomer with a real passion for the moon. In the 1870s, he studied the tides and the Earth-Moon relationship very closely. He proposed what became known as the fission theory. He imagined a young molten Earth spinning incredibly fast. It spun so rapidly, he suggested, that a large blob of molten rock was flung out into space. This blob, according to his theory, eventually cooled and solidified to become the moon. While this specific theory has since been disproven, Darwin's work was absolutely revolutionary. It would take new evidence gathered from beyond our own world to start building a theory that could truly explain our cosmic companion and its planetary nature. In 1975, a new idea emerged that would revolutionize lunar science. They suggested that the moon was formed from the debris of a colossal collision. When we take a tour of our solar system, we see a clear pattern. Giant planets are surrounded by a host of much smaller moons. Then there is Mars, the red planet. It has two tiny moons, Phobos and Deimos. These are not grand spherical worlds like our moon. They are small, lumpy, potato-shaped rocks. This is why the Earth-Moon system is such a puzzle. It simply does not fit in with its neighbors. Our moon is not a tiny captured asteroid, nor is it dwarfed into insignificance by its planet. If an alien astronomer were to visit our solar system for the first time, they would likely be struck by this strange pairing. It would stand out as a genuine curiosity, a departure from the cosmic norm. The Earth-Moon relationship is an outlier, an odd couple that breaks the established rules of our solar neighborhood. It's this very strangeness that makes the double planet theory so compelling. Instead, we might be looking at something far more special, a balanced partnership that challenges our fundamental definitions of what a planet and a moon should be. The most striking piece of evidence for the double planet theory begins with a simple measurement size. The moon's diameter is about 3,474 kilometers, which is roughly 27% of Earth's diameter. In contrast, the Earth-Moon system is more like comparing a tennis ball to a basketball, a much more significant pairing. They don't just orbit each other in a simple way. Instead, they both orbit a common point in space called the barycenter. Because Earth is so much more massive, this point is located inside our planet, about 4,700 kilometers from its center. Imagine for a second two ice skaters of different sizes holding hands and spinning. The smaller skater will travel in a large circle, while the larger skater will move in a much smaller circle around their shared center of mass. This is exactly what is happening with the Earth and the Moon. No other planet in our solar system exhibits such a noticeable wobble caused by one of its moons. This motion is a clear physical manifestation of the Moon's significant size and mass, providing strong visual evidence that our system is fundamentally different. This wobble is a telltale sign of a binary system. The Earth-Moon system is more like the second pair of dancers. This unique motion is a key argument for treating the system as a partnership of equals. The concept of the barycenter is where the double planet theory really comes to life. This invisible point, located deep within the Earth's mantle, is the true center of the Earth-Moon system. This shared orbit has dramatic effects that we experience directly on Earth. The most obvious is the ocean tides. The Moon's gravity pulls on the water on the side of the Earth closest to it, creating a high tide. Every time we look up at the Moon, we see the same face. The familiar patterns of the man in the Moon are always turned towards us. This is because the Moon is tidally locked with Earth. This is a direct, physical exchange of energy between two planetary scale bodies. The Earth is giving some of its rotational energy to the Moon, which the Moon uses to climb into a higher orbit. Every year, the Moon drifts about 3.8 centimeters further away from Earth. This is a slow but relentless process, a consequence of the conservation of angular momentum in the system. It behaves less like a planet and its satellite, and more like two components of a single evolving binary machine. One of the most controversial parts of the modern definition of a planet is the rule that it must have cleared its neighborhood. This means a planet must be gravitationally dominant in its own orbit. The Earth-Moon system acts as a single gravitational unit. Together, our two worlds have created a large, stable region of space that they dominate completely. The Moon is not just a passive object being dragged along. It is an active participant in this clearing process. Its gravity helps to stabilize our shared path around the Sun. It is not just along for the ride. It is a co-pilot on our journey through the solar system, helping to steer the ship and keep our path clear. Now, every good scientific debate has two sides. The idea of a double planet is captivating, but not all scientists are convinced. Many hold firm to the traditional view. Earth is a planet, and the Moon is its satellite. One of the main counter-arguments focuses on that crucial point, the barycenter. However, critics point to a very simple fact. The barycenter is still located inside the Earth. This distinction became very important in the debate over Pluto. Pluto and its largest moon, Charon, are much closer in size than Earth and the Moon. Charon is so massive relative to Pluto that their barycenter lies in the empty space between them. They argue that this is the clear, unambiguous definition of a binary system. If the barycenter is outside the primary, it's a binary. If it's inside, it's a planet-moon system. The official body responsible for naming and classifying objects in space is the International Astronomical Union, or IAU. According to this official definition, the Moon cannot be a planet. For now, the official classifications are Earth as a planet and the Moon as its moon. Critics of the double planet theory argue that this official stance should be respected. The giant impact hypothesis is a powerful story, but there is another way to look at the exact same event. This alternative view argues that the collision did not create a twin for Earth. Instead, it created a moon in a very dramatic fashion. In this interpretation, the outcome was not a partnership of equals. The Earth was the clear winner of the collision. It survived, grew larger by incorporating Theia's core, and was left with a ring of debris in its orbit. This makes the Moon a subordinate body by its very nature, born from material ejected from Earth. It is a child of the Earth, not a sibling. The stark differences we see today are, for some scientists, evidence of a clear parent-child relationship. The Moon is not a planet that failed to thrive. It is a moon that was never destined to be a planet. Thinking of the Moon as a planet alongside Earth does more than just change a label. It fundamentally shifts our perception of home. For all of human history, we have seen ourselves as inhabitants of a single planet. But the double planet theory offers a new, more complex address. We are not on a single world, but part of a binary system. Our home is not just Earth, it is the Earth-Moon system. The Moon is no longer just a beautiful light in the night sky or a destination for astronauts. it becomes our partner world. This view elevates the moon to a status it has arguably always deserved. We are not just Earthlings, we are residents of a two-planet system, the only one of its kind that we know of. We are part of a system, a celestial team. Earth did not evolve in isolation. Its entire story, from its violent birth to the development of life, has been shaped by its planetary companion. We cannot tell the story of Earth without also telling the story of the moon. It's a powerful reminder that even in the vast emptiness of space, we have never truly been alone. Our planetary partner has been with us all along. The double planet theory doesn't just change how we see our own world, it revolutionizes our search for life elsewhere in the universe. For decades, astronomers hunting for exoplanets have focused on finding Earth-sized worlds in the habitable zone. The double planet theory suggests we might actually be looking for the wrong thing. Maybe we shouldn't be searching for a solitary Earth, but for an Earth-Moon system instead. If our moon was a critical factor in making Earth habitable, then maybe a large moon is a necessary ingredient for complex life to evolve. It's not enough to be the right size and in the right place. A planet might also need a large companion. The next big challenge will be to find their moons, or exomoons. Detecting an exomoon is incredibly difficult, but the double planet theory gives us a compelling reason to try. Finding a large exomoon orbiting a rocky planet in the habitable zone would be one of the most exciting discoveries in modern astronomy. It would be a signpost pointing to a system that might be truly like ours. The theory forces us to think about planetary systems as a whole, rather than just individual planets. The real magic might happen in the gravitational dance between two worlds. The implications of the double planet theory extend deep into the story of life on Earth. We often take our planet's stability for granted. We have regular seasons, a predictable 24-hour day, and tides that follow a reliable rhythm. But this stability is not a given. It is a gift from the moon. Thinking of the moon as a planetary partner really highlights its role as Earth's guardian. Without the moon's immense gravitational influence, this wobble would be chaotic. Earth's tilt could swing wildly over millions of years, leading to catastrophic climate change with extreme ice ages and scorching heat waves. The regular mixing of water in tidal pools at the ocean's edge could have been the perfect chemical laboratory for the very first building blocks of life to form. The moon, our partner world, may not just have made life possible, it may have helped to kickstart it. The Earth-Moon system is a team effort. Earth provides the water, the atmosphere, and the right distance from the sun. The moon provides the stability, the rhythm, and perhaps even some protection from asteroid impacts. We may owe our very existence to this cosmic partnership. The moon is not just a rock in the sky. It is an essential part of the life support system for our planet, a planetary guardian that has shaped our past and continues to protect our future. The story of the Earth-Moon system is far from over. Future missions to the moon are already being planned by space agencies around the world. These missions will deploy new, more advanced instruments to study the lunar surface and interior in greater detail than ever before. As we plan for a sustained human presence on the moon, seeing it as a partner world gives these ambitions a new meaning. We would not just be visiting a satellite, we would be expanding humanity's footprint to the other half of our binary home. In the end, the power of the double planet theory lies in its ability to spark curiosity and wonder. It encourages us to look up at the familiar sight of the moon and see something new and profound, a partner, a guardian, and a second world that shares our cosmic destiny. Whether it is officially called a planet or not, the moon's true status is clear. It is an exceptional world, inextricably linked to our own. The story of the Earth-Moon system is our story, a tale of two worlds, a shared past, and an intertwined future, written in the stars and waiting for us to read its next chapter.